Greetings students. In this lecture, we'll study a small concept, that is the higher derivatives. Now, in the previous videos, we studied that whenever we are asked to find the derivative of a specific function, of a trigonometric function, of a hyperbolic functions, then how can we find it? Now, what if we are asked to find the second derivative or the third derivative or the fourth derivative of the function? Then how can we do it? It may seem very complex, but don't worry, it's really easy. If you are asked to find the second derivative of the function, you have to take the derivative again of the answer that you got by taking the first derivative of the question, which means that you have to take the derivative again of the derivative of the function. That is, first you have a function that is y is equal to f of x, and you took its derivative, and that is dy over dx f derivative x. And now you are asked to find its second derivative. Then what we will do is, you will take the derivative again of this particular derivative, which means that we would have a second derivative, and its notation is this, and you will have it as double dash x, as the dash represent the order of the derivative. In this case it is 1, in this case it is 2. So we have the first derivative here and the second derivative here. Now for the third derivative, we have to take the derivative again of the second derivative, and we'll write it as 3 bars, while for fourth derivative, we'll take the derivative again of this derivative, and we'll write it as 1/4. So the generic formula that we got is the nth derivative, that is d over dx, d n minus 1 y. Now why is it n minus 1? Because for third derivative we wrote 2, for second derivative we wrote 1, for fourth derivative we will write 3, and so on. So we have dn minus 1y over dxn minus 1, that is just a notation, is equal to d raised to power n y over dxn is equal to f of n of x. That is third for third, second for second, n for n, and 4 for 4 respectively. So let us just try to understand it with the help of an example. Suppose we are asked to find the derivative of x cube. It's not just a simple derivative, it is the third derivative. What we have to do is, we'll write it as f of x is equal to x cube, that is the function, and we take its first derivative, and that would be equal to 3x squared. We take the second derivative, and that would be equal to 6x, and then we'll have the third derivative, and that would be equal to 6. Now how did we do it? We had a function that is x cube. We took its first derivative, we got 3 before, and minus in the power, so we got 3x squared. That was the first derivative, and then we took the derivative of this again, so we got the second derivative. How did we got it? We know that constant comes outside, so it would be x squared, and then by the power formula we have 6x. And again for this one we have d over dx 6x. Now 6 comes outside, d over dx x, and the derivative of the variable is 1, so we have 6 as our final answer. So I hope you got the concept, and that's all from us in today's lecture.